Ciao friends, and welcome to a new video from SQL BI about DAX. In this video, I want to solve a simple scenario with both a DAX version and then some data modeling in order to make it slightly better. The scenario is quite simple. We want to force a measure to return 0 instead of blank, when the measure otherwise would return blank. This requirement is not very common, but sometimes it is useful to differentiate between blank and 0. The reason is, if a measure returns blank, Power BI will not show the row returning blank at all. Whereas if it returns 0, then it will show the row with a value of 0. And sometimes it is relevant to differentiate between blank and 0. Think about that. If you have a product in stock and you are not selling it, that is producing 0 sales, which is different from not having the product at all, because in that case you are not producing sales, but you couldn't. Therefore, blank looks like a good result, a meaningful result. Because the scenario is rather simple, we will solve it in different ways, and at the end we will also create a calculation group to solve the problem in a generic way for any measure that might be interesting. Let's get started. I want to show you first the problem with in a visual way, and then we start working on it. We have this report that is showing the sales slicing by year and by country region. Now, everything is working fine, but it's worth to note that the sales amount for 2008 in several countries is blank. It's not returning anything because Ireland, Italy, Poland and Portugal, they did not sell anything in 2008. Now, if you look at the report this way, everything is fine. The problem appears as soon as you filter a bit farther. If you only filter 2008, you see that now we have a problem, because I see the sales of France, Germany, Greece and the countries that created sales, but I no longer see Italy. So there is no clear evidence of the fact that Italy did not produce any sale. What I want to do is return a value so that I still see the value of Italy, Poland and Portugal with a value of 0. Now, there is a very simple solution to the scenario, which is either using an if statement or simply adding 0 to the value of the measure. Indeed, if the measure returns blank and you add 0 to it, you are not changing the value, but blank plus 0 equals 0. Therefore, you obtain 0 instead of the blank. We are going to implement it right now, but as you are going to see, this is not perfect because that shows zeros everywhere, even for combinations where you do not want 0 to appear. Let's do that. The first and simplest solution is to modify sales amount. Let me increase the font a bit. And compute the expression of sales amount plus 0. By doing that, blank becomes a 0. But look what happens as soon as I hit enter. Now I have zeros nearly everywhere. I need to get rid of the formula. I have 2005, 2006 that shows 0. I have my correct values for 2008, but then I have again 2010 and 2011 that show a 0. The reason is my date table is larger than just the set of days which are represented in the sales table. I have years earlier than the first sale, and I have years that are coming later. As such, I'm showing 0 everywhere. So despite being very simple, this solution is not the one that I want to implement. Let's go back to the original measure. What I want to do is control when that 0 will appear and when it will not appear. I want to control that, and I want to decide when to show 0 and when to show a blank. How do I decide that? Well, that is part of the business rules. You need to work with the customers or with your users in order to understand what is the difference between 0 and blank. In our scenario, we are going to use 0 whenever the product is available, but we are not selling it. And we use blank if the product is not available at all. The thing is, how do we know whether a product is available or not? We take the first date of sales, and from that point on, we will always show 0 if there are no sales in a specific period in time. Let me show you that again with the report. This is the same report that we were looking earlier, but now I'm slicing by product name, and I created a filter that filters some subcategories and some colors because I want to focus on just one product. And this is the product, Contoso Telephoto Conversion Lens X400. Now, this product sold something in 2008. Actually, it sold quite a lot of products. In 2007, then it didn't sell anything in 2008, and it started selling again in 2009. Now, its behavior is different than this marker zoom lens, for example, because that lens started to sell in 2009, and there's nothing before that. So what I want to do is to show 0 here, because this product was already available in 2008, but I didn't sell it. And I want to show a blank here because the product was not available at the time. Now, keep in mind what I'm doing is kind of cheating because I use the first date of sales as the starting point of a product. In a real world, it is likely you have different requirements. You probably have some data structure that tells you what is the date of first availability of an individual product. We don't have that in Contoso, and that is why we need to work with a bit of creativity in order to create the requirements. We can do that with DAX. So we can author a measure in DAX that checks whether the current date is in between the two boundaries. So when I'm here, I will check that this product actually has sales earlier than the current date. It has sales later than that. Therefore, even though the measure returns a blank, I want to return a 0. So my measure needs to do that. It needs to search for the first date with sales of the given selection of product, or the last date with sales of any product, and then verify whether the current selection is in between the two boundaries that I found. If that is the case, it will force the measure to return a 0. Otherwise, it just returns the value of the measure or a blank because the measure, of course, is going to be a blank. Let's do that with the code. Now we have the requirement and we can write our measure. Let's call it sales with 0. Okay. As I said, sales with 0, first of all, needs to compute the first date ever. We save it in a variable, first date, actually the first date with sales, that is calculate the minimum of sales order date. I need to use sales order date because I want the first date with sales. Then I will compute the measure here, for example, where I have a filter on the year and I need to get rid of it. But actually I need to get rid of any filter except the one on the product. So I can use all except sales product. That removes any filter from the sales table, from the expanded sales table, keeping only the filter on the product. Let's start by returning this variable. So we check that it is returning something meaningful. Okay, we have it. We can go here, get rid of sales amount, and we replace it with sales with 0. I'm not going to check individual values, but you see that for every product we have a different date, which is the date of first sale ever. Even though I have a filter for 2008, it's returning a value in 2007 and also in 2009 for the product that was not available still in 2007 or in 2008, sorry. Now that I have my first date, I need to compute the last date ever. And to do that, I retrieve the last date for which I have sales for any product. So the last date ever is similar to this, but now it needs to compute the maximum of sales order date, and I can remove filters, all the filters here. Let's retrieve last date ever, so we check that the code is indeed correct. And that shows for all the products the 31st of December 2009, which is the last date for which we have sales in any product. Last, we need the current date. So the current date, and to compute that, I can simply take the maximum of date. Now I need to use date because I want the current date selected in the current filter context. And finally, I need to define whether I want to force a 0. I want to force a 0 if the current date is less or equal. No. If the first date with sales is less or equal than the current date, and at the same time the current date is less or equal the last date ever. If that condition is true, that means I want to show a 0. Then I want my value, amount, which is sales amount. Actually, I can compute the results right. It's sales amount, and then I need to add 0 if for 0 is met. So if for 0 is greater than, if for 0, that's a Boolean value, then I add 0. And finally, I return my result. If I did everything correctly, now this measure should return the sales and 0 in the middle. I only need to format it as a decimal number. Okay. You see that it doesn't show anything here because this product starts selling in 2009, but it is now showing a 0 here as expected. So by writing some DAX code, we can solve the problem just by using DAX and nothing more. The problem of this solution is that it works just fine, but as I said, I'm kind of cheating because I'm using the sales table to define the business logic of showing or whether I want to show 0 or not. This might be an issue because I should have another data structure that tells me whether a product is available or not. In our scenario, besides, things are quite simple because we only have the first date for a product. Therefore, we could solve that by adding a column in the product table that stores the first date of availability of that product. And then we use that date instead of retrieving the first date with sales. But your business logic might be more complex than that. You might need to work not only with the product, but maybe with the store. You have stores that are open and close over time, and you want to show blank if there are no stores, but you want to show 0 if there is a store which is open in that given place. So both the store and the product become the drivers of the calculation that you want to obtain. In such a scenario, just relying on DAX is too complex. The DAX code would become really intricate, and at that point it starts to slow down. Therefore, there is another solution that is worth investigating on. That is, instead of computing everything with DAX, we create a table that stores the information whether I want to show 0 or not. And then we use that table instead of relying on DAX. This gives us the advantage that the calculation will become data-driven. It's driven by a table instead of being driven by DAX. That is more flexible and gives you more power because you can control the content of the table outside of your Power BI model. Let's do that. We need a table that stores the information whether I want to show 0 or I want to show blank. We will implement it using DAX, not because it's a best practice, but mainly because I'm fond of DAX, so I want to do everything in DAX, and because it's easier to work with DAX this way. But in your specific scenario, it's likely to be better to do that in Power Query or in SQL, because that avoids the problem of circular dependencies that you might find if you just rely on DAX. With that said, we are going to do that with DAX. So I need a table that contains the product key and the date for only the combinations where I want to show 0 instead of blank. And I can do that with a calculated table. So let me build a new table. Again, the font needs to be a bit larger. We call it 0 grain. And this table needs to contain the product key and the date. So what is the easiest and the best way to do that? Well, we need to first retrieve the last date with sales, then for each product the first date with sales, and then the dates in between the first date with sales of the given product and the last date ever. So we want the last date ever, and here I can just take the maximum of sales order date. Being a calculated table, I have no filter context, so that will be the last date ever. Then I need for each product the set of dates from the first sale up to the last date ever. So let's call these products and dates. What I want are the products, but I want more than the products. I want to generate for each product. I want the first date of this product. So first sale of product, that is going to contain the first sale of the given product. So I do simply calculate the minimum of sales order date. And that is going to contain the first sale of the currently iterated product by generate. Then I want the dates between first sale of date and last date ever. So let's call it dates. And I can use dates between date. And I want all the dates between the first sale of product and the last date ever. That is going to return a table containing dates, and then generate will merge it with the products. So I just return dates. Now, products and dates contains the full product table, but one row for each date where the product was sold. Out of this table, I'm interested in only 2 columns. So I restrict that, and I can compute the result. They just use select columns from products and dates, and I want the product key, which is a product key, and I want the date, which is date. Return result. That should be it. Let me check it, hit enter, it's gonna compute for a while. This table is going to be quite large. It's 2.283 thousand, so 2.2 millions of rows. It's rather large because it contains one row for each date and product. Now that I have my table, I need to build relationships. So I have, it's already here, my 0 grain table, and I want to build a relationship with date and with product. So product goes there, and date goes there. The cross-filter direction is correct. Date filters my 0 grain table, and product filters my 0 grain table. Now, whenever I place a filter on a product or on a date, that filter will go to 0 grain. And it's enough to count whether there are rows or not in 0 grain. So my code is going to become simpler. Let's build a new version of sales 0. This is the previous version, but we are going to build a new version. And let's call it sales 0 grain. That basically needs to check, it has a variable var for 0 Let's just check if count rows of 0 grain is greater than 0. If that is true, it means that there is a row in the 0 grain table, therefore I need to force a 0. And then I compute the result, which is sales amount plus if for 0, 0. You see how simpler the code became. We do no longer need to work on dates using my new technique because the business logic is now in the table. Let's format it as a decimal number. And then we can test it. From here, we get rid of sales with 0. And we use sales 0G, which is returning the correct value. You see we have 0 here and we have a value here. Now, this table, as you have seen, is around 2.2 millions of rows. Therefore, it's kind of a large table. We can reduce its size if needed. But to do that, we need to reduce the granularity. Instead of going at the day level, we can go at the month level. Going at the month level, we cut by 30 at least the number of rows in the table, because we will have 1 row per day per month instead of having 1 row per day. That can be done, but it prevents me from being able to use a regular relationship, a regular strong relationship between the date and my 0 table. Let's do that. It's probably easier to see that happening than to go on discussing. If I do not want to have date and product key, but I want the year month, I can do that by changing the code of my table. Instead of using dates between date, I can use the dates between to filter data and summarize. I'm thinking the easiest way to do that is to use a summarize. No, it's easier than that. I can use calculate table, use that as a filter and take the values of date, and then I need a column that contains the calendar and the year month. Now, this calculate table returns the values of the calendar year month for only the dates in between the two boundaries. If I do that, I will no longer have a date. Now I have date, calendar, year, month, number. And let's also call it the right way. Now, my table will no longer contain a date. It contains the calendar year, month, number, 2009-08. And as a consequence, I can no longer build a relationship with the date. But I can rely on a weak relationship, a many-to-many cross-filter relationship, because I can build a relationship between calendar year, month, number and calendar year, month, number. That is neither a key nor it's neither a key in date or 0 grain, but I have a circular dependency error. My bad, I use values. I needed to use distinct here. Now I should be able to build the relationship. No way, I'm still missing something. That's not distinct. Whoa, so where is my problem right now? Dates between works fine, this calculate table works fine. We have a dependency on product. Let's remove filters from product. Don't know whether this is going to fix that. Yes, there was a dependency from product. So I can build a relationship, but the relationship needs to be a many-to-many. And I don't want it as bidirectional. I want date to filter 0 grain. Now I have a many-to-many cross-filter relationship between 0 grain and date. And the code actually does not need to change, because the code says with 0g still compute the count rows of 0 grain. So it relies on the relationship despite the relationship being a strong relationship or a weak relation. It will work in both scenarios. So as you have seen, by building a table that contains the logic of whether to show a blank or not, the code becomes much simpler and you have more control on the table. I haven't shown you how large the table became by cutting it. Let me see that now it's 75,000 rows. So from 2 million to 75,000. Therefore, it's now tiny and it no longer is a problem in terms of size. But of course, we reduce the granularity at the month level, so we are no longer able to show zeros correctly at the day level. We will always use the month level also at the day level, which honestly seems totally reasonable. So by moving the logic inside the table, we gain more flexibility and we have a good solution that works with the price of one additional table. But as I promised, the last step is implementing everything by using a calculation group, because you would probably need to add the same business logic to a lot of different measures, and calculation groups are extremely useful for that. So we are going to create a calculation group that, when applied as a filter to the model, will force 0 instead of a blank on any measure that we put in the report. Let's do that. We need a tabular editor to do that. So we go external tools and we open tabular editor. And then it's just a matter of copying the code of the measure that is already working inside a calculation group. Let me go to tabular editor and I can create my new calculation group. And let's call it show blanks as. And I need one calculation item. Let's call it show blanks. That doesn't do anything. It just calls the selected measure, because the behavior is the same that we had earlier. But I want a new calculation item that we call show zeros. And for that, we just copy the code of sales 0G, yes, the one that we created. Let me just copy the code and we put it here. This time, instead of using sales amount, we use the selected measure. And that is the code of my calculation item. When show 0 is going to be filtered, as a consequence, the measure, whatever measure that is, will show a 0 instead of a blank. Let's give that a try. I need to save this, then go to Power BI Desktop, refresh, and now I have my show blank as calculation item. We can add it as another slicer. So let me create a new slicer. I just copy this, put it here, and then instead of using the color, we show the calculation item that shows show blanks or show zeros. Right now, the measure that I'm using here is still my sales 0 with G. Let's get rid of it and use just sales amount. You see, we have a blank here. But if I use show zeros, now the measure shows blank. So the logic of the measure does no longer contain show blank, but I can decide using a slicer whether I want to show blanks or whether I want to show zero. If I click on show blanks, I show blank, and if I click on show zeros, of course, I obtain a 0. So, as you have seen, the problem by itself was not very complex, but by writing some pieces of DAX code, we found some interesting scenarios and some interesting examples. The problem itself is just showing 0 instead of a blank, but then the problem becomes a business logic problem. When do we want to show blank and when do we want to show 0? Once we understood that, two different options. Either we work with DAX or we work with data model. That is what we always teach during both the mastering DAX and the data modeling training. You should know DAX, but as soon as DAX becomes too complex, then it's likely it's better to build the proper data model. Building the proper data model is extremely important for DAX developers, because the simpler the DAX, the easier the model your model will be and the faster it will be. So always think about different possible solutions to any of your scenarios. You start prototyping, then maybe you write DAX code, but before you deploy your model, you try different solutions and maybe you change the data model. For example, what we built during this long demo was a data model entirely built by using DAX, but as I said, that is likely to be better built with a Power Query or with SQL. But DAX is good for prototyping. Now we have a good prototype and we can move the logic back to SQL or to Power Query, build a table there so to avoid the nasty problem of circular dependencies, and we have a working model where you have full control over when to show blank and when to show 0. Enjoy DAX!